Coming to the question number 13. Construct DFA which accepts set of all strings over 0, 1, which when interpreted as binary number divisible by 4. So in my previous question, I have explained about divisible by 3. So that is in question number 12, I explained about divisible by 3. Now we'll see how you can answer for divisible by 4. So in binary, you have to check it out. That means the numbers are 0, 4, 8, 16 like this. And you can see 0 here. This binary representation 1, 0, 0 for 8, 1, 0, 0 for 16, 1, 0, 0, 0 like this. So many numbers. Now how to solve this one? Again, starting from Q0. Anyway, 0 itself is the remainder state. That's why Q0 itself is the final state. And I'll take 4 states. Q0, Q1, Q2, Q3. Why? Because divisible by 4 means I'll get 4 remainders. One is 0 remainder state, 1 remainder state, 2 remainder state, and this is 3 remainder state. So now you can see 0 remainder state. First of all, I'll check for DFA constraint here also. Q0 to 0 if I give. 0 in the sense 0 divisible by 4. Yes, it has to go to Q0 itself. That's why self loop for Q0. Q0 to 1. So if I give 1, what it needs to go? That means 1 in the sense, if you divide 1 by 4, that means the remainder is 1. So it has to go to 1 remainder state. Now Q0 to 0, Q0 to 1 will work. What about Q1 to 0? That means how you are reaching to Q1? By giving 1 to Q0. So 1 followed by 0. So 1 followed by 0 means which is 2 in decimal. So 2 in the sense directly it has to go to 2 remainder state. After Q1, if I give 0, it has to go to Q2, which is a 2 remainder state. After Q1, if I give 1, where it needs to go? 1, 1 in the sense which is a 3. It needs to go to 3 remainder state. That is Q3. That means from Q1, if I give 1, it needs to go to Q3. That means Q1 to, this is 0, this is 1. Q1 to 0 is over, Q1 to 1 is also over. Now from Q2 to 0. So how you are reaching to Q2? By giving 1, 0, you are reaching to Q2. That means by giving 1, 0, you are reaching to Q2. From Q2, if I give 0 here, where it needs to go? 1, 0, 0, which is 4. 4 in the sense 0 remainder state. That means 4 is divisible by 4. That means from Q2, if I give 0, it needs to go to 0 remainder state, which is Q0. So from Q2, if I give 0 here, it needs to go to 0 remainder state. Now from Q2, that means after taking 1, 0, if I give 1, what happens? 1, 0, 1 means which is 5. 5 in the sense 1 remainder state. Where is 1 remainder state? Q1 is the 1 remainder state. So from Q2, if I give 1, it needs to go to Q1. That means 1, 0, 1, 5, which is a 1 remainder state. This Q1 is a 1 remainder state. These are all remainders, remember. Now, going to Q3. How you are reaching to Q3? Check this one. So from Q0 you have given 1. From Q1 you have given 1. After giving 1, 1, you are reaching to Q3. So from Q3 if I give 0, 1, 1, 0. What is 1, 1, 0? Which is 6. So 6 in the sense 2 remainder state. Where is 2 remainder state? Q2. So from Q3 if I give 0, it needs to go to Q2. Now if I give 1 here in Q3, that is, the number is 7. So 7 in the sense 3 remainder state. Where is 3 remainder state? Q3 itself. That is self loop. Now you can check out for any number. Let us suppose I'll take the number 36. Binary representation is, so that is 100, 100. Now you check it out. If I divide 36 by 4, you will get the remainder as 0. That means it needs to go to Q0. So Q0 to 1, Q1, Q1 to 0, Q2, Q2 to 0, Q0, Q0 to 1, Q1, Q1 to 0, Q2, Q2 to 0, Q0. Yeah, finally you are going to Q0. You can check for 22. So 22 in the sense, which is a 2 remainder state. That means if you divide 22 by 4, you will get the remainder as 2. That means it needs to go to Q2. The binary representation is So now Q0 to 1, Q1, Q1 to 0, Q2, Q2 to 1, Q2 to 1, Q1, Q1 to 1, Q3, Q3 to 0, yes, Q2. So going to the 2 remainder state. Like this, you need to check it out for different numbers in binary system. So you can solve any sort of the question which is divisible by 5 in binary by taking the logic like this. We'll see some more questions in the next video lecture. Thank you.